Okay, this video is going to be an overview of 9.1, and also we're going to be looking at function operations from tables and graphs. So first of all, let's look at some of the functions that we're going to be needing to work with in this unit. We're going to be working with polynomials, and the polynomials can be either linear or quadratic. And we're also going to be looking at radicals. Now, your book does have rational expressions in here as well, but we are not going to be doing any problems with rationals. So, some things that you need to know for this section. You need to know how to evaluate functions. And if you're given a function, you need to know, like f of 2, you put 2 in for x and you can evaluate it. You also need to know how to find the domain of a function. And the domain of a function is a set of all x values for which the function is defined. For example, in a polynomial, the domain is from negative infinity to positive infinity, because you can put any real number in for x and you're going to get out a real number. For my second example, I have the square root of 3x minus 12. Now remember that you cannot take the square root of a negative number when you're in the real number system. So the domain of this function we can find by saying that this 3x minus 12 that's under this radical sign has to be greater than or equal to 0. So I can solve this inequality and say x is greater than or equal to 4. That's where this comes in right here. That's my interval notation for my domain. The next thing that I want to do is to look at finding a function value from a graph or a table. For example, if I want to find f of 1, remember that this 1 is my x value. So if I want to find f of 1, I come over here to the 1 on my x-axis and then go up to this point right here, and that is the point 1, 4. So my x value is 1 and my y value, or f of 1, is 4. Another thing that you're going to need to know for this section is function composition. Here I have f of g of x written two different ways, and I also have a diagram of what f of g of x means. I'm starting with some x value, putting it into the g function, and whatever I get out then goes into the f function. So that's just a real quick overview of what you learned about function composition in intermediate algebra. Okay, I'm going to be using the tables to find the following, if possible. Okay, that's the key, one of the key things to some of these problems here. All right, with the first problem, I want to find f of g of 19. Another way that I could write this is f of g of 19, where I am putting 19 into the g function, and then I'm getting out that value and putting it into the f function. So 19 goes into the g function. The g function is the table over here on the right. So 19 goes in, and then 8 comes out. Now I have to put 8 into the f function, and I get out 2. Okay. So what I did was put 19 into the g function, got out 8, so now I have to find f of 8, and that's going to give me 2. Problem B, I want to find g of f of 0. So here I want to put 0 into the f function and then put that answer into the g function. So another way to write this is g of f of 0. You go back up here and erase this from the first problem. Now I'm going to put 0 into the f function. So I put in 0 and I get out 14. So now I want to find g of 14. So I put 14 into the g function and I get out -9. So -9 is my answer. Okay, problem C, f of g of -6. So another way to write that is f g of -6. So I'm putting -6 into the g function. So -6 goes into my g function and I get out -10. So now I want to find f of -10. So I put -10 into my f function, and you can see that with looking at all of these values here for x, I don't have a -10. So this answer does not exist. Okay, now let's find f of g of 5. Here's another way to write that. Okay, we are going to put 5 into our g function. And actually, I can see that that doesn't exist. There is no 5 that I can put into the g function. So this answer does not exist. Okay, on this problem, I want to find f of -5 plus g of 4. So first thing I want to do is find f of -5. I'm looking on the graph that's on the left because that is the f function. Remember that this -5 is my x value, so I am looking on the x-axis for -5, and then I come down to this point right here. This is the point, -5, -1. So f of -5 is -1. Now I want to find g of 4. So on this graph that's on the right, I'm finding 4 on the x-axis. And I come up to this point. So this is the point 4, 1. So g of 4 is 1. And when I add those together, I get 0. On this next problem, I have f of 4 times g of 2. F of 4 means I'm putting 4 into the f function. So I go over to 4 on the x-axis, and then I come up to this point right here. This is the point 4, 3. So my f of 4 is 3. And I'm going to multiply by g of 2. So I need to look over here on the graph that's on the right. I find 2 on the x-axis, and I have this point, which is the point 2, -2. So my y value is -2. So I have 3 times -2, which is -6. Okay, with this first problem, I want to find f of g of 4. I'm going to start off by finding g of 4. So put 4 into the g function. I get out -2. So now I put that into the f function. I want to find f of -2. So -2 along the x-axis here matches up with a y value of 1. So that's going to give me 1 for my final answer. Okay, problem B, I want to find f of g of 3. And I'm going to rewrite that. So I'm going to start off by putting 3 into the g function. So along the x-axis here, I find 3, and I have this point. That's the point 3, 0. So now I want to be finding f of 0. When you put 3 into the g function, you get out 0. Now I'm going to put 0 into the f function, and I get out -3. Okay, problem C, I want to be finding g of f of 2. So here I'm going to start off by putting 2 into the f function. So put in 2 and you get out 1. So I want to be finding g of 1. I find 1 along the x-axis, and there's the corresponding point. I have the 0.14, so my output there is 4. And I'll give you a second to try D on your own, so pause the video and see what your answer is. Okay, your answer there should be -6.